Okay, and for our example problem today, we are going to be working on problem 5 out of chapter number 5. So chapter number 5, problem 5. And this problem is about the space shuttle. And it says, suppose the space shuttle is in orbit above the Earth. All right, so here we have the Earth and we have our space shuttle. Ooh, good looking space shuttle here. Okay, space shuttle orbited above the Earth um, at a altitude of 400 kilometers. Um, and it circles the Earth every 90 minutes. What is the centripetal acceleration of the space shuttle, and express that acceleration in G's? All right, good problem. All right, so we got the Earth, the space shuttle in orbit. Let's find that centripetal acceleration. Well, we know that we're going to need to know the speed at which the space shuttle is going around the Earth and the radius at which it's going around the Earth. So let's find the distance from the center of the Earth to the space shuttle. So basically, our radius is going to be equal to the radius of the Earth plus 400 kilometers. So to look up the radius of the Earth, you might need to use your physics textbook. If you turn to the front cover, there's all sorts of useful information there. And here I find the Earth mean radius is 6.38 times 10 to the third kilometers. All right, so that would be 6,380 kilometers. So to get the overall radius here, we would have to add 400 kilometers to that, and we would get the radius for this problem is going to be 6,780 kilometers. Now, since our acceleration is going to be in G's, which is in meters per second squared, I am going to express this radius in meters, all right? Since G's is going to be in meters per second squared, I'm going to put everything here in meters and seconds. Okay, so that's a good start to the problem. Well, how do I know the speed of the space shuttle? Well, let's do this. Last I remember, speed is distance over time. Well, if I know the time for one complete orbit, right? The time for one complete orbit, it told us is 90 minutes, right? So if I take that number and multiply it by 60 seconds, that would get the time for one whole trip, for one whole orbit. Well, what's the distance then? What is d for one whole trip? Well, that would be the circumference of the circle, or 2 pi r, okay? So really, it's just a little bit of math from there. So our speed would be 5,400 seconds. Pardon me, that would be the time. And then the distance would be 2 times 3.14 times our radius, which would be 6.78 times 10 to the 6th. Okay, and if I plug that all into my magic calculator here, I would get that the space shuttle is orbiting at a speed of 7,880 meters per second. Notice this is about 8 kilometers per second, so like 5 miles per second. It's moving pretty fast, right? Okay, so back to my original problem here. What is the centripetal acceleration of the space shuttle in orbit? So it would be equal to 7,880 squared divided by the radius of the orbit here, which would be 6.78 times 10 to the 6th. Okay, and if I do my math here, I get a centripetal acceleration of, rounding, 9.17 meters per second squared. Wow, that's not very much, huh? You're talking about space shuttles, you're kind of maybe expecting a big number. As a matter of fact, if we divide that by 9.80, we get that the centripetal acceleration is only about 0.93 G's, meaning the acceleration is 0.9 of the Earth's acceleration. Now, when you think about this, it kind of makes sense. I mean, you know, if this is 6,380 kilometers from the center of the Earth to the surface, you're really only adding, 400 kilometers. I mean, you're not adding. It's not like you're tripling the radius from the center of the Earth if you go into orbit. You're only increasing your effective radius by, less than 10%. So it would make sense that your acceleration is, goes down by less than 10%. Okay. So, Space Shuttle experiences a centripetal acceleration of 0.93 Gs while it's in orbit. And that is our answer to problem 5 of chapter 5. All right. We're going to take a super quick break here to get you your prize. All right, and your prize for listening to the lecture today is cute pictures of my dog, Raven, as a puppy. Oh, what a great reward. Oh, look at you, Raven. You had played with your toy too much and gotten stuck. Oh, Raven, you're playing in your doggy pool. Oh, you're so cute. Oh, so cute. Oh, look at those eyes. Look, Raven's saying, please, after you're done doing your AP Physics, please play with me. Please, please, please. Oh, look, I'm playing in the sprinkler. I'm so cute. Oh, so fun. Oh, dogs are cute. So, yes, Mr. Kirsten really does like dogs. Despite what he said about the Russian space program jokes, which we won't repeat here. Anyway, nice work, AP Physics students. We'll leave you with this image. Please do your homework. Please watch my videos and do your AP Physics homework. It'll make Raven happy. Oh, nice work.